Chapter 5 Chemical Bonding. Today we are going to discuss the following contents from Chapter 5, that is, formation of chemical bonds, types of chemical bonds, Ionic Bond, characteristics of ionic compounds, covalent bonds, single covalent bond, double covalent bond, triple covalent bond, and characteristics of covalent compounds. These all are the contents that we will discuss in our today's lecture video. So let's start our chapter 5, that is chemical bonding. So as you can see on your screens, we are starting our first content, that is formation of chemical bonds. As we all know that atoms combine and they form substances. So there is a force which is actually playing a role in the formation of those substances. The force which hold the atoms together into molecules or a crystal is called a chemical bond. So that force which is holding the atoms together is known as chemical bond. All the substances exist in the form of compounds and mixture. As I have already told you before, that substances are basically they are present in the form of molecules, not in the form of a single atom. Atoms basically combine and they form molecules. That's why we can say all the substance exists in the form of compounds and mixture. It indicates that there must be some force that holds atoms together in a molecule or a crystal. After looking at the formation of compounds and mixture, this made us to think that there is some kind of force which is holding atoms together. Atoms can't be held together on their own. So there must be a force, and that force is known as chemical bond. The nature of forces holding the atoms in a molecule or a crystal is electrical in nature. So what kind of force it is? The nature of the force which is holding atoms together in the form of compounds and mixture is electrical in nature. The electrons in the outermost shell of an atom are called the valence electron. As I have told you before in our previous lectures, that the electrons which are found in the outermost shell, in the last shell of an atom, are considered as valence electrons. Those electrons are called valence electrons, and there is no limitation how these electrons will come and reside in the last orbit, either of the three forces, that is complete transfer of electrons, sharing of electrons, coordinating, or by the other types. Electron can come in the outermost shell by the help of any kind of force, including these three. If the electron is in the outermost shell because of the complete transfer of electrons, it is known as valence electrons. Or if the electron come in the outermost shell by the sharing of electrons, it is also known as valence electrons. Why? Because these electrons are found in the outermost shell, which is the last shell of an atom, the outermost shell. Combination of atoms of different elements result in the formation of molecules of compounds. So what does it mean? If in case atoms of different elements combine together, what will happen? The result will be the formation of molecules of compounds. So it is not the only case that atoms of same elements can be combined together. Atoms of different elements can also combine together and they will form molecules of compounds. So now we all know how the formation of chemical bonds occur, and what will be the nature? The nature will be electrical of that force, which is holding the atoms together into molecules or in a crystal. Types of chemical bonds. So the first explanations of the nature of a chemical bond were advanced by W. Kossel, who was a German scientist, and G.N. Lewis, who was an American chemist. And this explanation by these two scientists was taken in the year 1916. They proposed two major types of chemical bonds. First was the Ionic Bond. The Ionic Bond is also known as Electrovalent Bond. It is formed by the transfer of one or more electrons from one atom to another to form ions. If in an atom there is a transfer of electrons, either of one electron or more electrons from one atom to another atom, it is known as Ionic Bond or Electrovalent Bond. And what will happen as a result of this transfer of electron from one atom to another? Ions will be formed. And what is an ion? As you all know, that if an atom loses or gains an electron, as a result of which they will get a charge, either a positive charge or a negative charge. That is, they will become cation or anion. If they will get a positive charge, they are considered as cations, and if they will get a negative charge, they will known as anions. So if an atom is losing an electron or donating an electron to another atom, they will become cation, they will get a positive charge. And if an atom is gaining or receiving an electron from another atom, what will happen? An extra electron or more than one electrons will be in their structure, and they will reside in their outermost shell, and the atom will become anion and get a negative charge. Second type of chemical bond that was proposed by the two scientists, that is W. Kossel and G.N. Lewis, was the covalent bond. So it is a bond that results when atoms share electrons. So what does it mean? It means that if a bond is formed as a result of sharing of electrons between two atoms, it is known as a covalent bond. Other types of bond include metallic bonds and hydrogen bonding as well. So the two major bonds that has been proposed by these two scientists was ionic bond and covalent bond. So now let's have a look at ionic bond. Ionic bond, in this type of combination, there is a complete transfer of one or more electrons from one atom to another. As we have discussed already, that if there is transfer of one or more electrons from one atom to another, what will happen? A specific bond is formed, which is known as ionic bond. The atom that transfers electrons gets positive charge. So it is clear to all of you now that the atom which is transferring electron, which is donating or giving electron to another atom, will get a positive charge, and the atom that gains electron, it means the atom which is receiving the electron, will get negative charge. So the atom which is having an additional electron by the transferring process will get a negative charge, and the one which is transferring electron, the atom which is donating electron, will get a positive charge. The strong electrostatic force acting between positive and negative ions holds them together. So there is a force which is known as electrostatic force, which is actually holding these positive and negative ions together. The attraction that binds oppositely charged ions together is termed electrovalent bond or ionic bond. So why we also consider ionic bond as electrovalent bond? because there is a force which is a very strong force known as electrostatic force, which is actually holding these two charges, opposite charges together, that is positive and negative charge. So because of the electrostatic force, positive and negative charge will hold together, and this attraction because of this electrostatic force between the oppositely charged ions binds them together. Therefore, we termed ionic bond as electrovalent bond as well. For illustration, let us consider the combination of sodium Na, which is symbol of sodium, and chlorine Cl, which is symbol of chlorine, atoms to form common salt sodium chloride, that is NaCl. As you all know that the symbol of sodium is capital N small a, that is Na, and symbol of chlorine is Cl, that is capital C small l. So the symbol for sodium chloride will be NaCl. As you can see, with Na, 2, 8 and 1 is written. What is this? The atomic number of sodium is 11. So these are the electrons which are found in sodium. So as a result of transfer of one electron from sodium, what will happen? Sodium will get a positive charge. Chlorine have 17 atomic number, that is have 17 electrons and protons in its structure, and by receiving one electron from sodium it will get a negative charge, and as a result of which NaCl will be formed. So it is the example that we have discussed before, that is NaCl. As a result of transferring one electron from the outermost shell to the shell of chlorine, NaCl, that is table salt, is formed. To have a better understanding of this example, have a look how this all transferring process happens. Basically, attractions between atoms forms chemical bonds, as you all know already about this. So ionic bonds, basically transfer of electrons takes place in ionic bonds. As you can see, so it is a sodium atom. There are 11 protons, as the atomic number of sodium is 11, so electrons will be 11 as well. As you can see, in the first shell there are 2 electrons, second shell 8, and third shell having 1 electron. Here is chlorine atom, and the atomic number of chlorine is 17, so it is having 17 protons and 17 electrons. First shell having 2 electrons, second shell having 8 electrons, while third shell having 7 electrons. Sodium have 1 in outermost shell and chlorine have 7 in outermost shell. So this 1 electron will be transferred to chlorine, as a result of which shell 3, that is outermost shell, will have 8 electrons. So now sodium have 11 protons with positive charge and 10 electrons with negative charge. So by transferring one electron from sodium atom, sodium will get a positive charge and will become Na positive, and the outermost shell of sodium will have 8 electrons. The structure is stable, and chlorine will have 17 protons with a positive charge, 18 electrons with negative charge. So chlorine atom will become Cl negative ion, chloride ion, by gaining 1 electron. So here NaCl is formed, that is having 2 charges, positive and negative, which are hold together because of the electrostatic force that is found between them. So ionic bond is formed. Now have a look at characteristics of ionic compounds. In ionic bond, it is impossible to say that any two ions are bonded to each other to produce molecule, but in the crystals of ionic compounds, the positively charged ions are mutually surrounded by each other in orderly arrangement. Thus, ionic compounds are solids at room temperature. So it means that because of the arrangement of positive charges, and the arrangement is orderly arrangement, because of that arrangement, ionic compounds are solids at room temperature. Second characteristic is that ionic compounds have high melting and boiling points because of the strong electrovalent bonds existing between the ions, as we have already discussed before. So because of the electrovalent bonds which are very strong, ionic compounds always have high melting and boiling points. Third characteristic is that ionic solids do not conduct electricity as the ions are not free to move. So in that case, once an ionic compound is melted, if we are going to melt that ionic compound, that it means if we are going to fuse the ions that are found in the ionic compound, then ions will be free to move, and the ionic solids which are now in the melted form will conduct electricity. Similarly, solutions of ionic compounds conduct electricity as they are not in solid state, so they will conduct electricity. Ionic compounds are usually soluble in polar solvents. So what are polar solvents? Polar solvents are solvents of high dielectric constant. The example of polar solvent is very common, that is water. And ionic compounds are insoluble in non-polar solvents. Non-polar solvents are organic solvents, as these solvents have low dielectric constant. And examples of such organic solvents, that is non-polar solvents, are benzene, carbon tetrachloride, and etc. That is CCl4 is known as carbon tetrachloride. They are mostly inorganic compounds. So these all are the four characteristics of ionic compounds that we have discussed today. Now have a look at covalent bonds. The shared pair of electrons which links the atom in a molecule is known as covalent bond, as we have already discussed before, that those bonds which are formed by the sharing of electrons, not by the transferring of electron, is known as covalent bonds. In covalent bond, the shared electron pair is commonly expressed by single short line, that as you can see in the small bracket, by this line covalent bond formation is expressed. For example, the halogens that is chlorine. So chlorine atom is taken as an example, possess an electronic configuration in which there are 7 electrons in their outermost shell. As you all know that the atomic number of chlorine is 17. So if we are going to distribute these 17 electrons and protons of chlorine, so the first shell will be having 2 electrons, second shell will be having 8, and the third shell will be having 7 electrons. That's how there are 7 electrons in their outermost shell, and lacking only 1 electron in order to attain the structure of an inert gas. What does it mean? It means that if chlorine will have one more electron in its outermost shell, then there will be 8 electrons in its outermost shell, and it will be a stable structure, and an inert gas structure will be formed or attained by having 1 electron. So chlorine is lacking only 1 electron. It means that there is only need of 1 electron to attain inert gas configuration. This structure may be attained by the halogens molecule, that is chlorine molecule, when both atoms share 1 electron for bond formation. So if there are 2 chlorine atoms and both chlorine atoms will share 1 electron with each other, as a result of which chlorine covalent bond will be formed and they will attain the inert gas configuration. Have a look at the example covalent bonds, that is sharing of electrons by atom. As you can see here, electrons will be shared between the 2 atoms, carbon, oxygen, hydrogen, and nitrogen. These 4 atoms mostly form covalent bonds. Like for example, hydrogen atom, 2 hydrogen atoms will form H2 molecule, that is by the sharing of their 2 electrons. Second example is of carbon dioxide. How covalent bond is formed? Here are 2 oxygen atoms Both have 8 protons, 8 electrons, 2 electrons in the first shell and 6 electrons in the second shell, that is the outermost shell. So there is need of 2 electrons to both oxygen atom. Here is a carbon atom, as you can see, 6 protons, 6 electrons, 2 electrons in the first shell, 4 in the second shell. So carbon wants 4 more electrons in its outermost shell. Oxygen wants 2 more electrons in its outermost shell. So therefore, as you can see, at oxygen atom will share 2 electrons and carbon will share 2 electrons as well, and the another oxygen atom will also share 2 electrons with the carbon atom, as a result of which carbon atom will get 4 electrons in its outermost shell, and oxygen atom, both oxygen atom will get 2 electrons in their outermost shell, as 8 electrons are required to form a stable structure, as a result of which CO2, that is carbon dioxide, is formed. Single covalent bond. Now we are going to have a look at it, as these are the types of covalent bonds. The first type is single covalent bond. In single covalent bond, only one pair of electrons is shared by the bonded atoms, in which each atom must share one electron. This type of bond is represented by single short line. For example, in the formation of hydrogen and hydrogen chloride molecules, only one pair of electrons is shared. So if there is only one pair of electrons which is shared between the bonded atoms, it is considered as single covalent bond. And the examples, hydrogen and hydrogen chloride, shows the formation of single covalent bond by sharing one pair of electrons between their atoms. Double covalent bond is the second type of covalent bond. In double covalent bond, only 2 pairs of electrons are shared by the bonded atoms, and each atom must share 2 unpaired electrons. This type of bond is represented by 2 short lines, as shown in the molecules of oxygen and carbon dioxide. As we have already discussed the example of carbon dioxide shows the formation of double covalent bond. And why carbon dioxide is considered as double covalent bond? Because in carbon dioxide, 2 pairs of electrons are shared by the bonded atoms. 2 electrons from one oxygen atom, 2 electrons from the another oxygen atom, and 2 electrons to oxygen atom from carbon side. That's how carbon dioxide is formed and considered as double covalent bond. Triple covalent bond is the third type of covalent bond. In triple covalent bond, only 3 pairs of electrons are shared between the bonded atoms, and each atom must share 3 unpaired electrons. This type of bond is denoted by 3 short lines, as you have seen that in single covalent bond, only one single line is used or to denote or to represent the bond, while in double covalent bond 2 short lines was used, and in triple covalent bond 3 short lines are used to denote triple covalent bond, as shown in the molecules of nitrogen and ethane, that is C2H2. These two molecules are the example of triple covalent bond, as in these bonds 3 pairs of electrons are shared. And now in the last, we are going to discuss characteristics of covalent compounds. Compounds with covalent bonds are usually made up of discrete units. Discrete units are actually molecules with a weak intermolecular forces. In the solid state, there are weak van der Waals forces between the molecules. Hence, covalent compounds are often gases, liquids, or soft solids with low melting points. In few cases, 3-dimensional covalent structures are formed rather than discrete units, that is molecules. Hence, diamond and silica, that is SiO2, are covalent but are very hard and have high melting points. Usually, covalent compounds have low melting and boiling points. So now it is clear to all of you that covalent compounds are often gases, liquids, or soft solids. So they have low melting points. And we all know that in solid state there are weak van der Waals forces between the molecules. But in some cases it happens that diamond and silica are formed, that is having three-dimensional covalent structure rather forming discrete units, so they will have high melting points and the structure will be very hard because they are three-dimensional covalent structures, not in the gas form or liquid form, or not having a soft solid structure. That's why they will have high melting points, while usually covalent compounds have low melting and boiling points. They are insulators because they do not conduct electricity, so we consider them as insulators. Covalent compounds are usually insoluble in polar solvents, as I have already told you before that polar solvent example is water. And covalent compounds are soluble in organic solvents like benzene, ether, and some other examples as well of organic solvents like carbon tetrachloride, that is CCl4. That's all for today's lecture. I hope that you have a great understanding of today's topic. Thank you for watching, and don't forget to subscribe my channel, and don't forget to give a thumbs up to the like button and share it with your friends as well. Take care. Have a nice day, everyone.